Lesson 6.2, Analyzing Discrete Random Variables. In the previous section, we completed an example involving the APGAR scores of newborn babies. Here we have that probability distribution recreated, and we're going to go ahead and use it to create a histogram. Now, when we do this, we take those APGAR scores, the values for our variable. They're going to go on the x-axis, and on the y-axis, we have the corresponding probabilities. When we look at these bars, we can see which events are most likely, along with estimating what their probabilities are. If we were asked to describe the distribution for this graph, we would use SOX as a reminder of what to include: shape, outliers, center, and spread. The probability distribution of APGAR scores is skewed left, that's our shape, with a center around 8. A range of 10. Remember, a range is a single number, so we don't want to say it ranges from 0 to 10, and no visible outliers. Since the distribution is skewed left, remember that that means the mean is going to be pulled towards that skew. It will be less than the median. It's always pulled towards the tail of that distribution, and the tail is the one where it's kind of trailing off to the side there. Pete's Jeep Tours offer a popular half-day trip in a tourist area. It needs at least 2 passengers for the trip to run, and it can hold up to 6 passengers at a cost of $150 per passenger. C is our random variable, and it's going to represent the total amount that Pete collects on a randomly selected trip. We're going to use our probability distribution here to make a histogram and describe the distribution. So to make our histogram, we're going to set our x-axis with a range that will include all the values in our variable. So total collected spans from 300 to 900. We don't have to start at 0, but in this case, we may as well, because that's not too far off from the minimum of our range there. Along the vertical axis, we have our probability. And when we make our scale over here, we're going to look for the biggest number that we have as a probability, and we'll set the top of our scale at just a little bit larger than that. We don't want to go up to 100% because that would just be a lot of empty space. So we'll go to 40, which can fit this one right here. Now we're going to describe the distribution. The total of collected money is roughly symmetric with a center around $600 and prices varying from $300 to $900. There are no unusual features. Now, we're often given a probability distribution, and we're asked to calculate the mean or the standard deviation. So to explain how this works, let's imagine a hypothetical 100 trips. Okay? Our probabilities are easy to apply to a sample size of 100. So 15% of the time, if we're dealing with 100 trips, that would be a total of 15 trips. The next one would be 25, etc., etc. To find the mean, we're going to add up all the values that we have together. So we have 300 trips at $15, then 450 at $25, etc., etc. The total is going to be all of those values multiplied by the number of trips they have, added up and divided by how many there are, in this case 100. But let's take a step back and let's look at this same situation just a little differently. It's broken up. Instead of one big fraction, we have a bunch of smaller fractions all over 100. And if we look at just this part, that 15 over 100 is the same thing as that 0.15. 25 over 100 is 0.25, etc., etc. So really what we can do is just take each value, multiply it by its probability, and add them all up. That's going to give us the mean of our distribution. So to simplify all that, when we have a distribution with a number of values and their associated probabilities, we find the mean by multiplying each value by its probability and adding up each of those products. The total sum we get is the mean or expected value of the distribution. Anytime we're asked to find the expected value, that's asking us to find the mean. So let's say we're looking at our probability distribution of APGAR scores for randomly selected newborn babies, and we're asked to calculate and interpret the expected value of X. That's asking us to find the mean, and we're just going to take each APGAR score, multiply it by its probability, and add all those values together. That gives us a total of 8.128, which means if we randomly selected many newborns and averaged their APGAR scores, we would expect to get the value that we just found. Now note that's not an actual possible value for an APGAR score. A baby could have an APGAR score of 8 or 9, but they can't have a value in between those because this is discrete data. It's okay to have an average that works out to something that's not possible for a single baby to have. Don't round the mean or expected value or averages to the nearest integer. We want it to be precise, and it's okay if it's not an actual valid value for that variable. That was all about the mean. How would we find the median? Well, the median is the 50th percentile. It's the middle of the distribution. So when we're looking for the median, we're looking for the midpoint, where we have 50% to the left and 50% to the right. So if we look at our table here, we can add up the cumulative probabilities. Cumulative means that we're just adding things together. So this 0.4 here comes from 0.15 plus 0.25. When we look at this 0.75, we're also adding in that 0.35, et cetera, et cetera. The median is going to be where we cross that 50th percentile. So once we get through all the 300s, we've crossed 15% of the data. Once we get through all the 450s, we've now crossed 40%. Somewhere in this next batch, the 600s, that's where we cross 50%. So we pass by the 50% and end up at 75%. So the median is 600. It's in that range right here. We're looking for the smallest value where the cumulative probability equals or is above that 50%. We could also do this from either direction. All right, so if we looked at it this way, all right, and just added those up, 0.5, 0.25, 0.6, we passed it. Our median is in that 600 batch. So mean and median are both fairly straightforward. The tricky one is the standard deviation. Remember, standard deviation is defined as the average distance from the mean. So we've already found the mean for a distribution. We're going to label it as mu x. To find the standard deviation, we take each value and we subtract the mean. So right here you see x1 minus the mean. Over here you see x2 minus the mean, x3 minus the mean, etc. So each of these values, we're going to subtract the mean, and then we're going to then we're going to square it. You see all the squares there, because we don't want them to cross each other out. Some will be negative, some will be positive. By squaring them, they all turn positive, or we can add them together. And as a last step, we multiply those probabilities. Okay, so an entire thing, x1 minus the mean squared, times the probability for that value. Then we move on to the next one, x2 minus the mean squared times its probability, on and on. So it is the sum of each x minus the mean squared times the probability. So let's find the standard deviation for the table showing the amount that Pete collects for his Jeep tours. We found the mean previously, and we got 562.50. So to start, we're going to take each of these values here, and we're going to find the squared deviations, meaning we're going to take each value, we're going to subtract the mean, and we're going to square that. That makes all of these positive. We can add these all together, but before we do, we have to take into consideration that these are not all equally likely. Some are more likely than others, so we're going to multiply each value times its probability. We'll see this in this next column here. So these are the weighted squared deviations. By weighted, we mean that we're assigning them to how likely they are to occur. Add all those up. That's going to give us the variance. Okay, so the sum of all these squared deviations weighted by their probabilities is $26,718.75. That's the variance. And to find standard deviation from the variance, we're just going to square root it. So we square root the sum of all those values that we had gotten on that previous table there. And our answer for the standard deviation is $163.46. As to how we interpret this, it's the same as it was previously. It's the average distance from the mean, which in this case, if we look at many Jeep tours, the amount of money that Pete collects typically varies from the mean of $562.50 by that standard deviation 163.46. Now, obviously, as the table gets larger, these get more and more complicated, but we go about it the same way. We found the mean on the previous slide as 8.128. So we take each value, we subtract the mean, we square it, and then we multiply it by that probability. On to the next one, 1 minus the mean squared times its probability, on and on until we get to the last one. If we don't, before we square root it, that's the variance. Square root the variance to get that standard deviation of 1.437. If we were to select many newborns, the baby's APGAR scores will vary from the mean of 8.128 by about 1.437 units.